Okay, the purpose of this video is to go over with you how to factor polynomials. It's probably one of the most difficult parts, I think, for a lot of high school students to get down pat, right? And I've developed I like to call it a little bit of a graphic organizer to help you go through all the different types of factoring you'll need to know. Now you'll notice what I have here, factoring polynomials, right? It's probably a good idea to talk about what factoring means. Factoring is really the opposite of distributing, right? When you think about it, there are many operations in mathematics. There's, the opposite of addition is subtraction. The opposite of multiplication is division. The opposite of squaring something is taking the square root of something. So this is just another one of those actions, if you want to call them action verbs, I like to call them action verbs, that we have. And we do these with polynomials. So the opposite of distributing a number is to factor it, or to find the factors that make up the polynomial in question. Now, we have different kinds of polynomials, right? We've got monomials where there's one term, binomials where there's two terms that are separated by an addition or subtraction, like right here, for example, right? 3x squared is a term, 9 is a term, and it's separated by an addition and subtraction. That's how you have two terms. That's why it's a binomial. Trinomials have three terms, again separated by additions and subtractions. You can have combinations of those. And then we have four-term polynomials, and of course that's four terms divided by additions and subtractions. Now in this particular video, what I'm going to do is show you how to factor some of the types of binomials that are out there. I like to think of this, I call this a graphic organizer. I like to think of this as like it's a pull-down menu. If any of you use like a word processing program, you have along the top, you have the menu, and you click on the particular heading, and out will come, the four parts that make up that particular heading. So think of it that way. Think of monomials having two subheadings, binomials having four subheadings, trinomials having four-term polynomials having two. And that will help you kind of organize your thoughts when you come to these types of problems, when you need to factor. Okay, so let's look at the first subheading under the binomial menu, and that is called common factors. And I'm going to put a little question mark after that, so because it's really you're asking yourself a question: are there any common factors to both of the terms in your binomial? Now, if I were to look at that, I would say, well, yeah, actually there is, isn't there? I can take out a 3 from both terms. So if I factor out a 3, what's left over? Now remember, factoring is the opposite of distributing, so I want to write this so that if I were to distribute it, I would get back up this direction. So it's just like going two different directions, right? Factoring this way, distributing goes that way. So I would say x squared plus 3. Now how do I check that again? 3 times x squared gives me 3x squared. 3 times 3 gives me 9. Now that's a fairly easy one, isn't it? And then you just take a look at that binomial and ask yourself again, is there anything more I can do to factor that? In this case, there really isn't. So that's what factoring, that's what common factors does. You find the common factor to both of your terms, pull it out, and then write over whatever is left over. Okay? Now, I can make this a little bit more complicated looking. Let me show you another example where it doesn't appear quite as obvious, right? Now, probably the first thing to recognize is that this is a binomial, at least the way that I have grouped it here. I've got a term here separated by an addition to this term. The term is in the parentheses. So I've got two terms inside parentheses separated by an addition or subtraction. Now ask yourself, is there any common factor to both sides of the addition sign? And the answer is yes, there is. It's x plus 1, isn't it? So I'm going to take out x plus 1, and then I'm going to rewrite what's left over. If I were to take out an x plus 1 out of x plus 1 squared, what would be left over? X plus 1. All right, because if I multiplied this times this, I would get x plus 1 quantity squared, wouldn't I? Now, plus. If I were to factor out x plus 1 from here, what would I get? I would get a 1, wouldn't I? Because it would be x plus 1 times 1 gives me that. So redistributing gets me back to the original problem, doesn't it? Now what's kind of interesting in this particular case is I've got a bunch of parentheses and brackets here. Some of them I can actually use I can condense some things. Now this one I'm going to keep together. But inside here, x plus 1 is really just x plus 2 when I simplify that problem. Now you might be asking yourself, but wait a minute, if I were to distribute this, or in other words, FOIL this binomial and this binomial, I wouldn't get this, would I? But in a way you would. If you were to FOIL it here, you would get back up to there. This is just a simplified answer, or the condensed version, if you want, of this particular factoring. Now the reason I'm offering you this example number 2 is to show you that they can make these binomials a little bit unusual to look at, right? You have to train your eye to look at different variations of binomials. They're not always going to be so easy like this one. They're going to have different combinations, so just pay attention to that. Okay? So we've just done common factors. Let's try one now with difference of squares. What's a difference of squares? We'll call this example 3. With a difference of squares, let's take a very, very basic one. Let's say x squared minus, I don't know, let's go with 36. Now, look at the words difference of squares. A difference is a subtraction. We got that part. Is x squared a square? Yes, it is. Is 36 a square? And actually it is, isn't it? It's actually 6 squared, so I can just rewrite it if I wanted to like that. Now, how do you do a difference of squares? How do you factor it? Well, you write down 2 binomial spaces, and then I like to put the signs in next, and I always put plus and minus. Then I go back up to the perfect squares on either side, and I say, okay, what's the square root of x squared? And the answer is x. Put those in the beginning. What's the square root of 36? And I say 6. Put those at the end. X plus 6 times x minus 6 is the factored form of this difference of squares. If you were to FOIL this, in other words, redistribute it, you would get this particular problem. Let's do it real quickly. We'll call that the check. So x times x, x squared. X times negative 6, negative 6x. 6 times x is positive 6x. And then 6 times negative 6 is a negative 36. Those cancel, and I'm left with x squared minus 36. Now you can do that with all those difference of squares, right? Put a binomial, put a plus and a minus, and then you take the square root of each of the parts and put them in the right spot. Let's make it a little bit more complicated looking so you can see what kind of variations we got. So let's do something like 1 over x to the 4th minus 4 over y squared. Now, that looks a little tricky, doesn't it? But don't be intimidated. Just go through and ask yourself the appropriate questions. Is that a difference? Yes, it is. Is this a square? Now, the way you do that is you just go to each of the individual parts. Remember, difficult problems are just a bunch of simple ones that they stacked up together. So ask yourself, is 1 a square? Yes, it is. 1 times 1. Is x to the 4th a square? Yes, it is. It's x squared times x squared. Is 4 a square? Yep. 2 times 2. And then is y squared a squared? Obviously it is. Y times y. So what do I do? You put down 2 binomial spaces. Again, you go plus minus. And now you take the square root of each of the individual parts and put them in the right spot. So 1 goes there, 1 goes there. X squared goes there, x squared goes there. 2 goes here, 2 goes there, and y goes there, and y goes there. Now, if you were to FOIL this, you would get back to the original problem, and I'll leave that up to you to go ahead and decide. The difference of squares is actually pretty easy. Okay, just make sure you follow the hints that I've just given you. Okay, so going back, we've covered binomials in this particular video, and we've covered common factors and difference of squares. We're going to continue on in different videos and maybe take these 2 or 3 at a time until we get through all of our menu. Okay? Good luck, and see you in the next video.